Hello everyone and welcome back to the channel. When I'm recording this video, we're right in the middle of the holiday season, that time of the year when you receive gifts, but every now and then there's just one small thing missing. In my case, it was a transport case. I recently got this amazing new device for my guitar, and I definitely don't want it to get damaged. So instead of buying a generic solution, I decided to do what we all love to do: design a custom-made case perfectly adapted to my needs. The case will be made of two main groups of parts: blue parts, which will be in direct contact with the device, black parts, which will form the external shell, and in this video we'll focus on designing the blue parts. To make sure nothing gets damaged by my design, I start by taking as many measurements as possible. The goal here is not to create a perfectly accurate model, but a functional reference model that I can design the case around. I'll go relatively fast on the part creation, but let me explain the key steps. I begin by creating a simple box, then use a neutral plane to add extrusions with a 20-degree draft in both directions. This makes the shape closer to the real object and will also help later during assembly. Once the draft is done, I add fillets. This order is important: draft first, fillets after, especially when working with large fillets. It's more robust and avoids rebuild issues. Next, I create two cuts to round the upper face of the part. To do this, I use the highest dimensions I measured and draw large radius arcs in both directions. As you can see, this approach is not extremely precise, but that's intentional. Taking exact measurements on this type of part is very difficult, and here functional clearance matters more than cosmetic accuracy. For these cuts, I use a surface cut through all in both directions. The advantage is that you cut the entire surface cleanly without creating unnecessary extra geometry, which keeps the model simple and stable. Once both cuts are done, I add a large 20mm fillet to remove all sharp corners, and then move to another fillet feature that now works with only a single selection. I then create a plane at the very end of the part. This plane will be used to sketch a small tombstone shape. As always, I rely heavily on sketch relations instead of stacking dimensions everywhere. This keeps the sketch clean, easier to edit, and more robust. To finish the reference model, I add a very simple representation of a 6.35mm jack connector, making sure I respect the overall dimensions I measured earlier. And with that, the reference model is ready. Now comes the interesting part: using this model to build the actual case. I create a new ordered geometrical set that won't merge with the reference geometry. This is a perfect use case for using a reference part to design new components around it. I start with a box that represents the bottom blue part. It's upside down on screen right now. Sorry about that, but I'll fix it later when designing the full case. I design everything directly around the reference model, a first rectangle to prevent the device from floating inside the case, a larger rectangle to represent the material. I start oversized on purpose and refine it later. Another advantage of geometrical sets is that they can have different colors, so I assign a different color to clearly distinguish the reference part from the new geometry. Whenever I design parts that will be in contact with something valuable, I always add clearance. It would be a shame if my own case damaged the device it's supposed to protect. I add offsets in multiple places: in the sketch, on the extrusion start plane, and on the extrusion end. In xDesign there are many ways to add offsets, and I use them whenever possible. Here I choose a 1mm clearance, and once again rely on my measurements to create the cut that will house the 6.35mm jack, its base, and the plug itself. I also use a section view to visually check that there's enough space everywhere, even though the original measurements were fairly rough. While I'm at it, I take the opportunity to create the cut needed for the main body of the part. That's the first half done. Let's move on to the second one. I start by creating a new geometrical set, and I take some measurement to add the right amount of material. For that, I just project geometry from upper part to keep the same dimensions, and I create the walls. And before I forget, I change color to avoid mistakes. You will see soon that in my case this won't be enough. I finish with a thin roof and upper shape is almost ready. Once everything is in place, I add a 5-degree draft on both parts. This will make insertion into the final case much easier, and it's very straightforward to do with the draft feature. There's one last feature needed to finish the upper part. One of the parts includes a small boss that links both halves together. If I don't add a corresponding cut, it would apply pressure on the device, and I definitely don't want that. So I create a simple cut using a basic sketch. Notice how I use relations to center the rectangle in just 2 clicks, even though it's not a center rectangle. I also make sure the cut is not too deep so it doesn't go all the way through the part. That wouldn't look very nice. Here I realize I designed on the wrong geometrical set. Colors didn't prevent my mistake. So I just drag and drop feature on the right one and everything rebuilds nicely. At this point the parts are ready to be printed. I let the slicer automatically arrange them on the print bed. And of course, this is printing time. Once printed, I quickly check that the device fits perfectly inside the blue parts. And everything looks good. In the next video, I'll use these blue parts to design the full case around them. This will give the final object a nice multicolor look, without spending hours on multicolor 3D printing. I'll also design a dedicated housing for the charging cable, because if I don't, I know I'll never remember where I put it. Finally, I'll need to design a hinge and a locking system to keep everything safe during transport. If you want to try this project yourself, head over to solidworks.com/makers and start designing today for a very affordable price. You'll also find plenty of tutorials and examples to help you get started. Thanks for watching and see you in the next episode.